Hi everyone, so another video. This is on kinematics, and this is where we have variable accelerations. So that's why we can't use the standard SUVAT equations that we're used to, you know, v squared is u squared plus 2as and all that kind of stuff. So just to put it in perspective on what we're doing, we are, in this first video, we're imagining Imagine that we've got a particle here and it's moving along a straight line. Sorry, the board was crap. So, okay, straight line. You've got a particle here. Let's say that's the origin, all right? And we know that x or s represents displacement, okay? Velocity, and we've got acceleration. So if we have some equation for x, let's say x is sine t, where t is time, x is the position along this x-axis, right? So the particle would start in the middle. What's happening as t varies, basically? So you know that when x is pi by 2, we know that sine pi by 2 is 1, and then it starts going back to 0, doesn't it? You know, if we follow that sine graph, okay, if this is x here and this is time, you can see that x is going between 1 and 0 and minus 1. So 1, 0, back to 0, minus 1, 1, 1, and it just keeps going like this. And if I was to draw a graph, that's where you can see our sine graph from, okay? So at the moment, we're just talking about particles moving along straight lines. So what's their velocity, what's their position relative to the origin, and what's their acceleration? And how do you move from displacement to velocity to acceleration where we need to diff? So to differentiate. So you know that v is dx by dt, and you know that a is dv by dt, which we already knew before, that the rate of distance is velocity and the rate of velocity is acceleration. Okay, so that's how we move from displacement to velocity to acceleration. We've said what's different here, that we don't have constant acceleration, and we know we're going along a straight line at the moment. How do we represent displacement? How do we represent distance traveled? This is super important, okay? Displacement, I'm just going to say this now. How do you figure displacement? So if the question asks, what's the distance from the particle to the origin, or what's the displacement, you're going to find x equals, and you're probably going to have a plus c, and you're going to need to find plus c, okay? And then you can sub in your, like if it asks you for when t is 5, you sub in t is 5, and that x value will give you the displacement from the origin. All right, so it's all relative from the origin, your displacement equation. Whereas if we want distance traveled, this is very different, isn't it? Distance traveled, we know that anything to do with distance traveled, we need to draw the graph, because when you integrate it, distance traveled, we know if you have a velocity curve and you integrate a velocity curve, the area is your, each section is each bit of distance traveled, isn't it? Okay, so if you integrate the whole velocity curve, then you're going to get displacement. But if you split it up into sections like we have now, you'll get distance traveled. So essentially what I'm trying to say is displacement, anything to do with displacement, you're going to need the plus c, find c. Anything to do with distance traveled, you're going to need to integrate with limits, right? So you're going to need to know what the curve looks like, whether it's above the axes or below the axes, because that's going to affect it, isn't it? Because that bit's negative, that bit's positive, that bit's positive. So you would need to find this negative section separately and times your area by minus 1, okay? And that's what we're going to get on to. So let's do some examples. So we've got, I'm trying to go for these two examples quickly because the last one is the most important one. So I know I've got a kinematics problem just looking at it. So I'm just going to put my x to v to a and diff. So I want you to always write that down to remind you that I need to differentiate to move in that direction and integrate to move to the other direction. So a small metal ball is moving along a magnetic field. It has mass 0.2, okay? Moving in a straight line, so we already know that, under a force F. The displacement is given by x equals 3 sine t, 2t. Find the magnitude when t is pi by 6. So we know F equals ma. So f equals 0.2 because it told us the mass here, and now we need to know a. At the moment we have x is 3 sine 2t, so I need to move from x to v to a, so I need to differentiate. So v is dx by dt, so using the chain rule, that's 6 cos 2t, but I need a, which is dv by dt, so now I can differentiate this thing, so that's minus 12 sine 2t. It wants it at t is pi by 6, so at t is pi by 6, our a is going to be minus 12 sine 2 pi by 6, so that's going to be the same as minus 12 times root 3 over 2, so that's minus 6 root 3, okay? Whack it into our f. Remember it says the magnitude of f, so magnitude of f is got to be positive, so 0.2, the mod, both sides of a, which is minus 6 root 3, so the answer is minus 1.2 root 3. Sorry, not minus, because we've modded it all, just 1.2 times root 3, okay? So 1.2 root 3. Right, next. Okay, particle is moving along the x-axis, cool. At time t seconds, the velocity is this, so straight away, velocity is 8 plus 2t, take 3t squared. I know I'm working with some function of t then, so I'll put my x to v to a and diff, that will help me remember. And it's telling me, it's giving me some initial conditions. Why is it doing that? Already that's hinting to me that I'm going to have some plus c somewhere and I need to find what that is. So at time is 0, x, the displacement from the origin, is 4. So it's saying when time starts, if that's the origin, my particle is 4 away, okay? And it's telling me that the velocity is in the direction of x increasing, so it's going to the right, right? So part A says find the magnitude and direction of acceleration. So to move from v to a, I need to differentiate. So a is dv by dt, which is going to be 2 minus 6t, and it wants it at t equals 3. So therefore, magnitude of a, I need to put my mod signs in there, yeah? So 2, 6, 3. So that's mod minus 16. So that's 16 meters per second squared. And then quote your direction because it asks for magnitude and direction. So as it's negative inside the mod, it must be decelerating basically. So direction negative x-axis, okay, or x decreasing. X decreasing is probably a bit better. Okay, part B, find the distance of P from naught. So be careful there. Just because it says distance, that doesn't mean distance traveled. It's saying distance from O, which means displacement. Okay? So what's the displacement when t is 1? How do I move from v to x? Well, I need to integrate. So x is the integral of v dt. So that's integral 8 plus 2t take 3t squared dt. So 8t, t squared, t cubed, don't forget your plus c, right? So you know how to integrate, so that's why I'm going quite quick. How do we find that c? Well, that's where our initial conditions come in. So at t is 0, x is 4. So if I plug that in, x is 4, t is 0, 0, 0, c. So c must be 4. Therefore, the displacement curve is 8t plus t squared minus t cubed plus 4. And it wants the displacement when t is 1. So I literally say that t is 1, x will be 8 plus 1 minus 1 plus 4. So 12 meters from the origin, because displacement is already defined as distance from the origin. Okay? Part C, the total distance traveled. So I think I'll just clone this. Whoops. Get rid of that. Okay, part C, the total distance traveled between 1 and... Right, so the minute I see total distance traveled, I should be thinking, right, I need to know what the curve of the velocity looks like. So distance traveled means I need velocity curve, and I need area under the curve. All right, so velocity curve area gives you distance traveled. So first I need to draw the velocity curve. So that's 8 plus 2t minus 3t squared. I need to know what it looks like. I need to know if some of the area is below the axes or above. So if I factorize that, okay, what's that? 4, 2, 3, 1. So 3t, and we've got plus and minus. Okay, so therefore, if we set that equal to 0, that will tell me when it crosses the t-axis. So that's minus 4 by 3, and t is 2, which means I can draw this now. So minus 4 by 3, t is 2, it's a quadratic and it's a negative 1, so it's going to do that. And I'm looking at it, distance between 1 and 4. So 1 is here, and 4 is here. So just like when we started integration, definite integration, we need to split this up. So distance traveled equals the integral between 2 and 1 of our velocity. That's positive already, but this bit is negative. So minus the integral between 4 and 2 of your velocity curve. Okay, so I won't finish that off. So you need to draw your velocity curve when asking for distance traveled. That's the main point I'm trying to make here. Okay, this is a really important example then. So we've got a split function, okay, which I don't think you can read that well. All right. Okay, t is 5. So hopefully we can see that better. 10t minus 2t to the 3 by 2 here, right? So that's 3 by 2. T is the 3 by 2. Okay, so greatest speed. First off, greatest speed in that interval between 0 and 4. All right, so greatest speed, normally when we do greatest speed, as we're going in this section, we're looking at the 10t take away 2t to the 3 by 2. All right. We're going to need to know something about that curve, aren't we? I mean, we could do, if you're thinking greatest, then you're probably thinking the maximum. So we could differentiate it, which 3t to the half is 0. That's good. And then we could bring the 3t to the half over. We could divide by 3 and then square everything. So we get t as 100 over 9 and then sub that into velocity. But 100 over 9 is 100 over 9 is the same as 11.11. That can't be right, can it? Because t can only go between 0 and 4. So we need to know something about, so that is what we would do if we didn't have this constraint here. But we need to know something about the curve. We need to know what it looks like. And to cut a long story short, we could just take out the t, okay, 2t to the half, and we could start mapping this and working out what this thing looks like. So we know it crosses at 0. We know that 10, so t would also be 25. If I made 10 minus 2t to the half 0, moved it over, divide by 2 and square it, okay? So I know it looks like that. And that curve is essentially going to look like this, and it goes on forever. So it looks a little bit like a negative quadratic curve. But what you need to know is that between 0 and 4, it just keeps getting bigger, basically. And you could differentiate it again, and you could differentiate it once, and then you could prove that it's increasing and all these kind of things. But essentially, I just need to whack in t is 4. All right, so that's where 24 comes from. So you need to watch out for that. Right, so you have to know something about what the curve looks like. The distance of p from O when t is 5. This is important here, okay? Distance of p from O, so that's telling you displacement when t is 5. Yes, t is 5 is in here, but the problem is that this thing starts from 4, doesn't it? Okay, so essentially, let's do it. So we know x to v to a, right? So if I look at this bottom function, we've got v is 24, take away. Can you see I can take out that 1 over 2 all to the 4? So that's 1 over 16. T take 4 to the 4. I can integrate this. So x is the integral of v, and I'm going to get 24t, take away 1 over 16, and now it's just a chain rule, isn't it? So plus 1 to the power, divide by new power. So 5 times 16 is 80. So we are here, okay? And I could quickly differentiate that to check. Now the problem is we have a plus c here. What is that plus c? So we would need initial conditions, wouldn't we, to find that plus c. But where do we get those from? Because at the moment, this thing starts at t equals 4. So we know t equals 4, but we don't know what our initial x is. All right, and how do we get that initial x? Well, we need to go to the previous curve, because essentially this curve takes over from where this one left off. So actually, I need to find my initial conditions from the top one. So if we have x equals the integral of v dt for the top one, that's going to be 5t squared, take away t to the 5 by 2, and then that will become 4 by 5 plus c, right? So can we see from here that, for example, so you can see from here that we don't have enough information to answer this because the question didn't give it to us. But I'm going to say that the question, so this question here needed to say as an initial condition that at, say, t is 0, x was 0. Let's say it started at the origin. So I could plug that in here. So if x is 0 and t is 0, then 0, 0, and you're left with t, left with c being 0. Okay? So if you have your x curve established from the step that you are leaving off from, you can generate your initial conditions from here, because we need when t is 4. So when I put in t equals 4 into here, I will get my corresponding x value. Okay, so 5 answer squared minus 4 by 5 answer to the power of 5 by 2. I get 54.4. Okay, so 54.4. All right. And that means I can now answer the question, because I can go back to my second curve, which was on this one here, and I can sub in these initial conditions to find this missing c, and then I can put in t equals 5, because this is the part where t equals 5 is valid. All right? So 55.4 is 24 times by 4 minus 180. 4 minus 4 to the 5 plus c. This will go, I get 54.4 minus 24 times 4. Okay, so it tells me that c is minus 208 over 5. So therefore my finished curve, 24t minus 1 over 80, t take 4 to 5 minus 208 over 5 is my curve. If I want to know the displacement, when t equals 5, I just need to whack in 5. So at t equals 5, x will be 5, 24 answer minus 1 over 80, answer minus 4, power of 5, minus 208 divided by 5. So the displacement is 78.4 meters to 3SF. Okay, that's good. Last one, the last couple. So the time at which P is instantaneously at rest. So again, if I clear this off because it's getting pretty busy. So the time when P is instantaneously at rest. So that's saying when T is 0, basically. When V is 0, isn't it? So for T is greater than 4. So 24 minus T take 4 over 16 to the 4. When is that 0? you're rearranging to get your value of t. So if I would move that over there, times by 16, 4 fruit it, and you will get t equals, let me just do that because I'm getting lazy. So 24 is t take 4 to the 4 over 16, times by the 16, 24 times 16 is 384, and then 4 fruit that, 384 is that, and then I'm plus 4 to it. So I should get t is 8.43, okay? Now, the last bit, the total distance traveled by p in the first 10 seconds. Again, distance traveled, the minute I hear distance traveled, I'm thinking I have to draw the graph. I have to know what this thing is looking like. And I won't do it because we've run out of time, but distance traveled, I need to know what the graph looks like. So this first bit of the graph between 0 and 4, we agreed from earlier, looked a bit like that. Okay? We need to know if this bit dips below the x-axis and the t-axis. And we know that it does. Okay, so remember this is the velocity curve that we care about. We know it does because the maximum, the instantaneous rest, sorry, when v is 0, is when t is 8.43. So when this curve takes over, we know it goes down at 8.43 here, and then it's going to keep going down up until the first 10 seconds. So what you need to do to find distance traveled, you're going to integrate between 4 and 0 of your top curve. Okay, and then you're going to have to integrate between 4, so plus 8.434 of this section here of this curve, 24 minus t minus 4 to the 4 over 16, and then you're going to have to minus that remaining area. So it's a big problem. In class we're going to do one very similar but a bit harder. Okay, so that's 22 minutes. We'll stop there for that one.